Okay, in this video we're going to talk about JavaScript conditionals. Okay, so this topic has to do with programmatic flow. So the idea of a normal JavaScript program, if we're creating a JS file, I have this file called conditionals.js. It's just a plain text file. I'm going to type in some JavaScript code here, and whatever JavaScript code I type, I can execute this file using the node command from my terminal. So I'll start with a simple console.log, and we will log starting new program. Something like that, something simple. Okay, so the way the execution flow happens is the text is read and Node looks one line at a time and tries to execute code. If it sees the comment characters, the slash, that tells Node to ignore this line. Comments are for the authors of code, right? So we can look at these comments, and Node does nothing as it reads, and it reads one line at a time, and if it encounters a blank line like here, it does nothing and moves on to the next line. Here finally we get some valid JavaScript code. So it's going to examine this. This is a JavaScript expression. A function call must be evaluated. You pass in the argument data, and then somewhere in Node, this is a built-in function. Console is an object stored in memory, and then .log is a property of that object that happens to hold a function. We call that function with the left and right parentheses, and we pass in our argument data. So this is one piece of argument data. This is a string, right? And then once this is executed, there'll either be a result or not, but we're not printing out the result. So in this case, in a JavaScript file, we're not going to see any result here, right? But we are going to see this printed to the screen because that's what console.log does. However, if we were to store something in a variable here called result, this variable would be undefined if I print that out, console.log result. Okay, and after each line you want to have a semicolon. Alright, so let's see what this does here. We're going to run node and conditionals. Okay, so very simple starting program. Console.log prints out whatever arguments you supply to it and prints it out to the terminal. Now here we see this is an expression, it just returns undefined. So either this function has an explicit return that returns undefined, it could have a return that doesn't return a value, which by default is undefined, or it might not actually use the return keyword at all, in which case all three of those return the undefined value when a function is executed. But we know functions can return values. Okay, so this is a JavaScript expression despite the fact that it returns no value. Okay, so we have using the semicolon. Yep, always gotta have that. So we start our program, and as I said, JavaScript goes, or Node rather, interprets this file and it goes line by line, top to bottom, and then from left to right, of course. So this is all well and fine, but what if we want to do something conditionally? What if we have, depending on some set of inputs, we want to run certain code, and in another set of inputs, we would want to run different code? Okay, so the way we do this is with an if, elif, or else statement. Okay, so there are three sort of clauses that you can use. So let's start with an example program. We're going to have a score, and that score is going to represent maybe a score on a test or something, and this score can be between 0.0 and 100. Alright, so this is just how we're defining it. This isn't part of JavaScript. This is just part of our definition of what this variable can hold. Okay, so let's say we get a 93.2 grade, right? And I want to say if the score is greater than, let's see, it would be 60.0. Right, that is the line for failing. So if that's the case, then we're going to log to the console So if our score is greater than 60.0, than Alright, so this is the cutoff. If you got 60.0, that's a D minus. So that means you got better than an F. Alright, so we can save this. Now what's going on here? This is the if statement, and here we have in parentheses. You must have parentheses. In some languages you don't, but in JavaScript you must have the parentheses. Inside of those parentheses goes a Boolean expression. So a Boolean expression, as we talked about, expressions always evaluate down to one value, right? So this expression evaluates to a value. What's the value that we get here? Well, we're comparing a number. So score is holding a number. We're comparing that to another number, and we're asking the question, is 93.2 greater than 60? So the result is either a yes or a no, right? In this case, it's a true or a false. So true, false values are Boolean values. Okay, so this is a Boolean expression. Boolean expression is any expression that can return a Boolean value. Right? So if score is greater than 60, in our case, because we set score to 93.2, this is true. So the way an if statement works is if the expression you supply is true, then this code executes. Right? So let's try it with 93.2. You got better than an F. Right? Perhaps we better tone down that. It's not that exciting, right? You got better than an F. Now, otherwise, we can say else. And then console.log. You got an F, or you failed. All right? So this is an if statement with an expression. If that expression is true, we execute this code. If it's not true, we don't execute the code. Here, let's change our value to something that would be a failing grade. So 58.1. Right, so now our score is 58.1. Is 58.1 greater than 60.0? This is false. So if this is false, we skip over what's in the if block. Now remember, in JavaScript, the code blocks must be designated with curly brackets, or curly braces as they're called sometimes, right? So we must use the curly braces, and this is the code block. Now we still indent because it's easier to read the code when we indent like this, but it's not technically required in JavaScript. We could have something like this, right? But that's a little bit harder to read, especially when you have multiple lines. I could have another console.log over here. Right, and this gets a little bit difficult to read. So we'll undo that and we'll go back to this convention. But the main point here is JavaScript doesn't need you to indent your code like a programming language like Python. Indentation is required in Python by the Python code parser. However, in JavaScript, the curly brackets are the only things that designate what code is inside of a code block. So you don't technically have to indent, but by convention you always should. Alright, so here we have a situation. 58.1 is not greater than 60.0, and so this becomes false. If this is false, we do not run what's inside the code block, and if there's an else statement, then we will run what's inside of that else. So if this is true, run this, else, so this is sort of like saying otherwise, we will run this. So that's the basic if-else statement. All right, so we can run this node conditionals.js, and it says you failed. Right, so this was false, and skipped over this, and ran the else. Now I'm going to comment this out just so we can verify. If I don't have the else statement, all it does is skip over what was in the if block. There's nothing else to do. Right? It would just continue down here. And we could have something like program done. And semicolon. Alright, so one line at a time. It's going to print starting program. It's going to define the variable and set a value. Then we have this conditioning, and this is where our programmatic flow or flow control. What code gets executed next? We're controlling the flow of execution, right? So if this is true, then the flow of execution goes here. If not, we skip over it, and the flow of execution goes after the if block. Now this code is commented out, which means as far as node's concerned, it's effectively deleted. All right, so we can run this starting program, and this evaluated to false, so we just skip that over. Where if we have the else, if this is false, then we run this code in the else statement. Okay, so we get the you failed. Now, what if, let's change this around again a little bit. We're going to say if score is less than 60.0, we're going to say you failed. You got an F. All right, and then we're going to say else if, missing my keyboard keys today, else if, and we have another code block, but we have to have something in here. So else if what? If score is less than 70. So if the score is less than 70, then this is going to be you got a D. And then for the else statement, we're just going to put something else. All right, now let's examine this. I left my semicolon off there. So as we examine this, if our score is less than 60, this is going to execute. And we're not going to execute anything else, any of these other conditions. Anything that starts with an else, the else if or the else. These are all skipped entirely. So if this is true, we run this. And then skip everything else and continue execution down past the entire if-else block. All right? So if this is false, then we go down and check to see if there's an else-if statement underneath. If there is, there's an expression there. So if this is true, we execute this. If not, then they'll execute the else. So it's important to realize that in this case, right, if score is less than 60, this will execute and nothing else. If score is less than 70, if it's between 60 and 70, right, this will have been false. So if our value is 65, for example, 65.1, 65.1 is not less than 60, so that's false. So we skip over this. Is 65.1 less than 70? Yes, it is. So we print out you got a D. Right? And we can run this and test this. So what we can do is have multiple else if statements. We want else if score is less than 80. Right? And so this might be a good opportunity to copy and paste because we see the pattern here. All we need to do is change this number and the letter grade that you get. So I'm going to copy this and then come down here and paste. And so else if score is less than 90, this is going to be a B. And if the score is less than 100, that's going to be in the A range, and then otherwise we will say A+. Something like that. So it's important to note here in an if, elif, any number of else-if statements that you have, and then even if you have an else, only one of these code blocks is going to be executed, right? In no situation are multiple code blocks in this scenario going to execute. So this, only one will execute in an if, else, if, else. And one will definitely execute. So what do I mean by that? Well, in this scenario, one of these is definitely going to execute. If all of these are false, then the else command, the code in the else block is going to execute. One of them will certainly execute. If that's true, it's going to be this one, and the rest are ignored. If that's false and this is true, it'll be this one, and the rest are ignored. But one of them will definitely execute. And that's true if you have an if-else. There should be a space there. So we have a situation with an if, ElseIf, else. Okay? And that's even true of just an if-else. So as long as there's the else, that means at least one of them is always going to execute when that code is encountered. All right, so let's take a look at this. We can put in a value here. We'll say 75. We got a C, and then we can say 88. You got a B. 94. There's the A. And say you got some bonus points. There's 101. So that's the A+. Only one of these will ever execute because of the way we've written this. Now, if we write this differently, if we remove these else's, it is possible for more than one of these to execute. So the else if is important here. Because of the way we've coded this, I've removed all of the else's except this final else block, right? So if your score is less than 60, it's going to say you failed, right? But then it's going to, the code execution, the program flow is going to go back here. Now we have a brand new if statement. And so if your score is also less than 70, now it's going to say you got a D. Okay, so the use of the else is very important. So when we look at this situation, let's say we have the value 55. Okay, score is less than 60. So 55 is less than 60. This is true, so it's going to log out that you failed, which is correct, right? But then this entire if statement is done. We didn't use an else, and we didn't use an else if. So the entire if statement is finished, and program execution continues after the if statement. Okay, and it moves on, and now there's a brand new if statement. In the previous way we coded this, this was all part of one if, else statement. But now we've got multiple if statements. So now this is a new comparison. Is 55 less than 70? Yes, it is. So it's going to print you got a D, even though that's not really logically what we want to show here. We're trying to show if you got, based on your score, what your letter grade would be. So this is an example of how you have to be careful when using ifs, else ifs, and else's. So if we don't have the else here, let's run this, and we're going to see that instead of just one of these executing, in this particular case, the way we've coded it, all of these will execute, and this gives us bad information. Right? So it says like, you failed, you got a D, a C, a B, and an A. And that's all because we left off the else's. So I can copy that and paste these back in here. All right, and then if I run it, we're back to the program working properly. Okay, so that's an important thing to take away. If you have an if, else, else if, it's entirely different has an entirely different meaning if you leave off these else's. Okay, they're then separate if statements, and then multiple code blocks can execute. So if it's one gigantic if, else if, and any number of else ifs, and an else statement, one of these is guaranteed to execute, one and only one. But if you leave these else's off, that changes exactly how this is coded. All right, it changes which code blocks can be executed. Right, more than one can be executed in that case. All right, so this is a simple example of if, elif, else. We can make this a little bit more interesting by adding the math object, and we can say math.random. So math.random creates a random number between 0 and 1, and it can include 0 and it cannot include the number 1. And so what we do here, this is going to be a decimal number less than 1 and equal to or greater than 0. So if I wanted to make a score, like just some random score, if I take this number, right, say the number we get is 0.67 and then a bunch of other digits. Right? If I wanted to make this a score, my scores are supposed to be between 0 and 100. Right? That's the standard score. It's a percentage. Right? So what I can do is I can multiply this by 100. So if I take 0.67 and multiply by 100, that basically makes this 67. Okay, so that's what I'm going to do with this random, math.random. This is a function that's going to return a decimal between 0 and 1. And then if I multiply that by 100, now we have something that looks like a score. Okay, so I'm going to print out the score. And just print it out like this. And when we use console.log, you can pass it multiple arguments, and when you do, it puts a space in for every argument. Right? The space here doesn't matter. It's the comma that matters. The comma is saying this is the first argument and this is the second argument. So in console.log, it's going to print out this string, and then because we have a second argument, it's going to automatically print out a space, and then it's going to print out the next argument. And so for every argument you have, if you have one of those commas, it's going to print out a space as well. So let's look at this. We'll run this program, and it's going to generate a random number between 0 and 1, and then it's going to multiply that by 100. And so now we should see, as I run this multiple times, so our score is 37. So that means we failed. Okay, 29. So most of these are going to be failures because the random, this is a pseudo-random number generator, and there's an equal probability that any number in between 0 and 1 is picked. Okay, so that means the vast majority of these are going to be you failed, because the numbers between 0 and just less than 60 are all failures. So that's 60% of these. Right? So 60% of the time we can assume that there's going to be failures. 10% of the time is going to be D's, 10% will be C's, and 10% will be B's, 10% will be A's. And we should never get here because of the way we designed our number. It's not possible for us to get over 100 based on this. Okay, because this number can only maximally be a little bit less than 1. And so if you multiply that by 100, it's going to be 0.9 something. Okay, so we keep running this, and we'll run it a few times until we get something that's not a failure. So there's a C, right? So our score is 74.89, and then we got a C. And so we can run this. And know every single time we run this, it's a different number, and that's what math.random does. It calculates a number that sort of behaves randomly. It's not truly random, so that's why we call it a pseudo-random number generator. And that is not particularly important for the things that we're doing, but if you get into advanced topics like cryptography, the random number generator becomes very, very important. And you wouldn't want to use something like this for cryptography, because even though this number appears random to us in most cases, programmatically we can crack this and prove that it's not random, and that has security concerns as far as cryptography goes. Okay, so just know this is pseudo-random. It's a pseudo-random number generator. You might see it in print if you're reading articles. Pseudo-random number generator. You might see this in different articles. It comes up a lot, especially with security magazines and that sort of thing. All right, so there's a little information on conditionals. One extra thing we can do is we can nest these conditionals. All right, so one thing I might want to do is say if we're in this else if, right, I might want to have another if inside of here, and I could say if score is less than, oh, what's the line? I think it's 73. Then we can console.log oh, I guess this is if you got a D. So if it's less than 63, we can say, but it is a D minus. And then we could say else if score is greater than, what is it, 68 or 67, something like that. If it's greater than 68, then we'll say console.log and it's D plus. All right, and then otherwise it's just a normal D. Okay, so we could say, we could have an else statement here too, but we don't really need it. But this is just an example. The point being, the entire point of this is programmatic flow. We're controlling the line-by-line flow of the code execution. And with the conditional, one of these items, one of these code blocks is going to be true. So here in the case where we get something between 60 and 70, this entire code block is going to execute. All right, so let's look at that. I'm going to comment out this line. I'm going to duplicate it first. And here we're just going to look for something between 60 and 70. So this is going to be, let's make it a 61. So this is going to be 60 is less than 70, right? And then it's also less than 63. So we should see this execute because this was true. So this entire block of code is going to execute. So we print out you got a D, and then we see a new if statement. Is it less than 63? Yes. So this executes, and then we'll skip over this one. All right. Again, we're controlling the flow of execution, skipping certain lines or executing certain lines based on some Boolean expression. And we can nest that functionality. Okay, so you got a D, but it's a D minus. What if we upped it to 69? Okay, you got a D and it's a D plus, right? What if it's in between those? So neither one of these would be true. Okay, there is no else statement, so there's no third thing that will execute. So an else if statement will not guarantee that one of these things executes, right? Previously we talked about if it's an if, else if, and an else, then one of those things is guaranteed to execute. One will definitely execute. But if you don't have that else, then it is possible that one of the, like, nothing gets executed. So one of these code blocks doesn't necessarily execute because there is no else statement. So this is going to be that case. When we have, this is the score as, let's say, 65, we see 65 is, this is false. It's not less than 60. This is true. It is less than 70. This is false. it's not less than 63, and this is false, it's not greater than 68. So neither one of these are going to execute, but since this one was true, that code is going to execute. Now it's important to realize that JavaScript is still going to test this. It's going to execute this expression and either get a true or false result. It has to execute this, and that's how it knows to run the if. It doesn't know if it runs the if until it evaluates this expression. Okay, and then I could change the value of score, and it could affect things. Like if I change the value of score inside of here, it would change whether or not this would be true. So you have to be careful about changing values inside your flow of execution, right? So let's run this one final time, and we see score is 65, and then you got a D, and neither one of these were executed. All right, so that's conditional logic. This is flow control, programmatic flow. You can nest these inside of code blocks. And next we're going to talk about loops. And inside of a loop you can have if statements, and inside of if statements you can have loops and that sort of thing. So code blocks designate sections of code that will be executed under certain conditions, right? And that all has to do with flow control.